Welcome to SS1503, Interpretation of Test Scores, Study Session 14. Introduction. This lecture is to educate the students on how to interpret the results of scores obtained after psychological tests had been administered. A test score remains useless unless interpreted by the test giver. So, in this lecture, the students will be exposed to some techniques used to interpret test scores. Objectives. At the completion of this lecture, students are expected to 1. Apply various methods appropriate to interpret the test score of test takers. 2. Appreciate the relevance of the measures of central tendency in interpreting test scores. 3. Utilize the measures of variability in the interpretation of the test scores. Content. Psychological tests, like many measurements of human characteristics, can be interpreted in a norm-referenced or criterion-referenced manner. Norms are statistical representations of a population. A norm-reference score interpretation compares an individual's results on the test with the statistical representation of the population. In practice, rather than testing a population, a representative sample of group is tested. This provides a group norm or set of norms. One representation of norms is the bell curve, also called normal curve. Norms are available for standardized psychological tests, allowing for an understanding of how an individual scores compare with the group norms. Norm reference scores are typically reported on the standard score Z scale or a rescaling of it. A. Criterion reference interpretation. A criterion reference interpretation of a test score compares an individual's performance to some criterion other than performance of other individuals. For example, the generic school test typically provides a score in reference to a subject domain. A student might score 80% on a geography test. Criterion reference score interpretations are generally more applicable to achievement tests rather than psychological tests. Often, test scores can be interpreted in both ways. A score of 80% on a geography test could place a student at the 84th percentile, or a standard score of 1.0 or even 2.0. Take 2. On a geography test could place a student at the 84th percentile, or a standard score of 1.0 or even 2.0. B. Norm reference interpretation involves comparing an examinee score to that of others in a normative sample. It provides an indication of where the examinee stands in relation to others who have taken the test. Norm reference scores include developmental scores, e.g., mental age scores and grade equivalent, which indicates how far along the normal developmental path an individual has progressed, and within group norms, which provide a comparison to the scores of other individuals whom the examinee most resembles. C. Criterion reference interpretation. It involves interpreting an examinee's test score in terms of an external pre-established standard of performance. False negatives and false positives. The sole reason for using psychological tests is to help answer the question, do we accept this person or not? And since psychological tests aren't magic, mistakes will be made. Even when a qualified psychologist makes a decision based on all the available evidence, there will still be doubt and shadows of doubt. Thus, a false negative mistake occurs when a person truly qualified for a job is rejected. A false positive mistake occurs when a person not truly qualified for a job is accepted. Now, according to simple logic, if you try to minimize false negative mistakes, you maximize false positive mistakes, and vice versa. Most employers, therefore, try to make their decisions so that the false negative mistakes are minimized, especially when good employees are hard to find. Norms and testing. To understand norms and statistical assessment, one first needs to understand standardization. Standardization is the process of testing a group of people to see the scores that are typically attained. With a standardized test, the participants can compare where that score fell compared to the standardization group's performance. With standardization, the normative group must reflect the population for which the test was designed. The group's performance is the basis for the test norms. A group of scores can be summarized by a measure of central tendency. The most familiar of these measures is the arithmetic average, most technically known as the mean, M, and is found by adding all the scores X and dividing the sum by the total number of items, N. M is equal to EX and N. Another measure of central tendency is the mode or the most frequent score. In a frequency distribution, the mode is the midpoint of the class interval with the highest frequency. A third measure of central tendency is the median or middle score of the distribution. For a normal distribution, the median is equal to the mean. This is not true for every distribution. Further description of a set of test scores is given by measures of variability, or the extent of individual differences around the central tendency. A familiar way for reporting variability is in terms of the range between the highest and lowest score. However, a much more serviceable measure of variability is the standard deviation, symbolized by SD or S. The standard deviation SD is an index of the width of a frequency distribution. The smaller the standard deviation, the closer the scores cluster around the mean score. The greater the standard deviation, the greater the differences between the scores and the mean. The standard deviation is computed by calculating the average squared distance of the scores from the mean and taking the square root of this value. Step 2. Find the mean, median, mode, and range. Mean equals to M equal to EXN equals to 40/10 equals to 4.00. Median equals to 3.5, score in the middle position. Mode equals to 3 and 4, the most frequently occurring scores. In this case, there are two modes. Range equals to 9 minus 2 equals to 7, the largest score minus the smallest score. Within group norms. Nearly all standardized tests provide some form of within group norms. Within group norms, which evaluate an individual's performance in terms of the most nearly comparable standardization group, have a uniform and clearly defined quantitative meaning and can be used in most statistical analysis. The main types of within group norms are percentiles and standard scores. Percentile scores express an individual's relative position within the standardization group in terms of the percentage of persons whose scores fall below that of the individual. Standard scores. Standard scores express the distance between an individual score and the group mean. If we equate a standard deviation to 1, we can express a raw score as being X number of standard deviations above or below the mean. To do so, We change our raw scores into a type standard score, that is, z-scores. The equation for finding the z-score is z equals to x minus m stroke sd. Correlation. The term correlation simply refers to the degree to which two or more sets of data show a tendency to vary together. The strength of the positive correlation coefficient can vary from 0.00 to 1.00. The Pearson R is the most commonly used measure of correlation, sometimes called the Pearson product moment correlation. It is simply the average of the sum of the z-score products, and it measures the strength of linear relationship between two characteristics. The positive increase correlation coefficient can range from 0.00 to 1.00. The closer to 1, the stronger the relationship. End of study session 14. Thanks for listening.